I really like the setup of this stage, obviously, because we are today going to talk about how we in Continental are implementing AI for tires. So, okay, it's working. Has anyone here tried to purchase a tire online? You can reach your hand if you have to. Okay, so a couple of you, I feel your pain. So when you are purchasing a tire, you have to provide information regarding your tire, namely the dimension of it. And as you can see in the website, sometimes it's not as straightforward as it seems. So we decided to also tackle that issue in Continental. Moreover, we have other businesses like fleet solutions and smaller warehouses that need to keep track of their tires, namely because they want to know, like, a tire also has an expiration date and they want to be aware of that. So we, with the help of a smartphone, want to be able to identify the tires, to recognize those numbers, to document, and then to, in case if you are a final consumer, to give you, another tire that you can buy that's similar to yours. So the numbers that I'm talking about, I'm just going to give a little bit of a lesson, is this one here, which is related to dimension of the tire, and also this one here that are called the dot numbers that are related to where the tire was produced and also the year. We are also going to talk about what we call serial numbers, but they do not appear in commercial tires, only in specialty tires, so think about trucks. So this is where our journey is going to begin. In 2017, we decided to start identifying the dimension of the tire. This actually led to a bachelor thesis, which I'm not going to pronounce because my German is not that good. Then, in 2019, we decided to expand the solution to also detect the DOT numbers and the serial numbers. So this is the final solution, is Macy. As you can see, we are taking a photo of our tire. This is going to detect the zones that we want to have an interest to decode. So let's just give a couple of seconds. And here are the outputs. Also, continuing on our journey, in 2021, we created a visual perception provider framework. And lastly, in 2022, we decided to develop our project and convert Macy into a software development kit. So this is what we are going to talk about today. So, how was this possible? Let's first start to talk about the data science details. First thing first, we need data, right? Our data collection is right now a little bit more than 5,000 images of tires from different brands, lighting conditions, perspectives, and also different countries, and with the text orientation randomly. These images were taken by our core team, so even with our personals and work phones, and they were later annotated with a software that's designed for that purpose. Right from the bat, we noticed some problems. First, the black on black text, because we make, dark tires. Apparently, data maker makes them white, but ours are black. So we need to be able to, identify these numbers on the black background. We also have, arbitrary oriented test, because we are not going to ask you to align the tire. Then we also have scale variance, because some people are not going, to scrunch down to take the photo of their tire. And lastly, every brand has their own text, fonts, they have their own sizes. Even though the numbers need to be in a specific order because that's global, we like to have also our personality in there somehow. So let's start about how we decided to approach this problem. First thing first, we need to detect the areas that we want to, then recognize our characters. So this is what we call the region of interest detector. Later, we need, to align the boxes with the horizontal axis. And only after that, we can have, our OCR algorithm making the predictions about the characters. So, starting with the region of interest detector. This is an object detection task. It's CNN neural network architecture. And we also do augmentation operations like translation, rotation, scale. These are actually the results that we have from accuracy at the moment. And as you can see, we split them between the regions that we have of interest. So we have the dot code, the dimension, and the serial number. Afterwards, we have our text orientation part. So the first thing first is that we take the bounding box and then we align with the horizontal axis. And two things can occur. Or it's either, perfect, already ready to be used, or it's flipped. So we need to understand if it's flipped or not. So we have here a convolutional also neural network. Like I said, it only has like 2 outcomes. And this is used for all the regions of interest, so this is the result of accuracy. After all of that, we go to the part where it comes the OCR algorithm. And because we are talking about text in an image captured in an outdoor environment, this is called a scene text recognition. And we can have 2 approaches here, a context-aware or a context-free. A context-aware approach, it uses semantics to understand how the characters are going to be recognized. So we use language models for that. And this works really well for dimension and DOT numbers because they do have to follow a structure. And this has to be universal, automotive rules. However, in the serial number, which is just random numbers from 0 to 9, we don't have that kind of semantics. So we use a context-free approach. Obviously, these 2 approaches, have pros and cons. On the context-aware, the characters can be reasoned according to the dictionary that we provide. It's more robust against occlusion. So if their part there is not being shown in the image, it's most robust against that. However, the model is more complex. And if, for example, if we started to change the way that we do the serial numbers and the dot numbers, like universally, it will be harder to use the same model. So we will have to also train with that. And then, when it comes to the context-free approach, it's more flexible, it's less biased. However, it does need a post-processing layer, and it doesn't work with partial occlusion. And also, no information is shared between the predicted characters. So this was not the best solution for these 2 regions of interest. These are the results of the work accuracy, and we are also using here the Levenstein distance. Just a small note, this is not an updated version. The serial number, actually, we now have better results, which comes close to the other 2, so in the 90 percentile. And take into account that this is not the metrics with the accumulator errors that we can have down the pipeline. So, again, quick recap. We take the photo, we detect the areas that we want to recognize, we orient them, and then we recognize it. So now we are going to talk a little bit more about our deployment. So let's go back to 2017, when the first product owner talked to the data scientist saying that they want to detect the dimension of the numbers in the tires. And the data scientist was like, for sure. Then in 2019, he was like, okay, to data science number 2, I want you to detect the DOT numbers. Data science number 2 said, of course. And this happened. I think we can all see what's happening here. Completely different tech stacks. So in 2021, when the product owner was like, oh, okay, this is really nice, business loves it, let's merge this into one single solution, it was complicated. This actually happened to us. So that's why in 2021, we started to create a visual perception provider framework. So this is a framework that data scientists in our team, and also in Continental, not just our team, can develop faster and consolidate image recognition solutions. So this is an infrastructure that we don't need to create every single time. And this does not mean that it's going to remain the same for the rest of the year. We do try to update, and we do a lot of research. The main thing about here that's also really good is we are all in IT areas. We do face sometimes turnover, and also we are expanding, thank God. But this means, new people coming along to these projects, and we wanted to make sure that they have a proper knowledge in an easier way. So having a framework like such really helps along the way. So right now, I talk how we already have this visual perception framework in place, but now we had to think, okay, so we are going to deploy the model in a long time, how we are going to retrain it, because we don't want to just, we want our solution to be better throughout time, right? So this is how currently we retrain our models. So every time you take a picture, this is stored into our S3 bucket, and then the V7 Labs, which is also the program that we use to make the annotations, it mirrors the S3 buckets. Then our model makes an inference, and if that falls below a certain threshold, someone from our team has to go there and label the data, and then we use it to retrain the model. If this model is better, which we hope it is, we record in MLflow. So this is currently how we retrain our models. So now, let's go again to our story. In 2022, we start to gain attention, even inside Continental, from the different parts of the business area. And they all wanted this solution. So what we decided to do, like you see here, was we decided to make a software development kit. In this way, we can have a package that can be used across all the entire business. And it's much easier to deploy. After that, I'm going to talk about our journey, which is our DevOps pipelines. So as you can see here, we have two options, an offline and an online. And you may think, why the offline option? So remember back when I told you that one of our customers are also fleets and warehouses? Well, there's a problem that I know that a lot of people will know that work in the industry, is that sometimes our cell provider does not work in these types of environments. And we cannot use it. So we decided also to have an offline option to accommodate that. Or if you want to try it out just for fun, and if you are in the desert, why not? So to do so, we convert this into Onyx runtime. And then we store, these models into our Amazon S3 bucket and the Amazon DynamoDB. And when you are online, if we have a new model, we will ask if you want to update. If so, we will do an over-the-air transfer. So this is the offline pipeline. When it comes to the online, as you can see, we do work a lot with Amazon AWS services. So essentially, you take a picture, this gets a call to the API that triggers the Lambda, and then in the SageMaker makes the prediction, and it propagates back to your phone. So these were our DevOps pipelines, and this closes our story into Macy. So because we did not want to just do, again, a huge recap of what I just said, this is a short presentation, we decided to leave here with some sort of tips. And I know that this may be a little bit obvious for some of you, but it's always good to remember, right? So when it comes to data, don't always swipe right, but don't be too picky. So actually, we do have more images than just 5,000 images. Some of them were not useful. And you don't want to have your data to be like with those unuseful pictures, but then again, you don't want to bias your model. So we have to make sure that we include data, but not like photos that you have half of the tire, for example. That's not going to be useful. Then when it comes to machine learning, what we say here is to do not settle, research, and keep trying different approaches. This is actually something that we do a lot in Continental, is we do try to keep in current with the latest releases and the newest technologies. So it's something that our team does a lot, to research and to keep trying new frameworks that might help. And if those are better, we want to also broadcast. So this also relates a little bit with our idea of standards to share the knowledge. Then when it comes to DevOps, mind your resources, accuracy is not everything. This is really important, especially because in the offline inference, we are converting the models to Onyx runtime. And sometimes the model can be, like 2 percentage points better in accuracy. But if it's too complex and it is too big and it doesn't work well in your pipeline, sometimes it's better to keep the one that does also have a good accuracy, but adjust better to that pipeline. Then we have something here which is brace for impact, know where and why it failed. Because, we are still humans, we are not robots yet, so even when we go to, the prototype phases, sometimes our pipeline crashes. But it is important to know where did it crash and why did it crash. So, having your tests and everything, it's really important. And last but not least, and this is one of the main ones, is implement data science standards. It's standards, which we know is not the most attractive word, but it's really useful. And this is something that is a buzzword in our team. And we found this to be really helpful. And implementing standards, like I said, it not only helps ourselves, but it helps for a continuous improvement and also for when we want to join new people into our business. So, we arrived to the end of our presentation. This was a short one, but I hope you enjoyed and you got to see a little bit how we use data science and especially computer vision in Continental. And thank you so much for coming here.
All right.
No way,
Thanks so
I'm
much,
just
folks.
speaking the water.
Yeah.
Because I'm also a little bit
I
under
thought
the
you ran
weather.
away from questions. All right, have a seat. We have a few questions over here. We'll start with the first one from Daniel Ribeiro, senior data scientist and tech lead at NOS. And the question is, do you have a tire wear inspection in your roadmap? What about degradation or defect inspection?
Degraded or in fact this?
Defect inspection, yes.
Okay, so currently the way that we make sure like the tests that we do to the images are all manually and they are making like in a certain time period. So at least once a year we do that. But I think this pretty much helps answer the question.
Yes. And I think the next one can also relate especially about this degradation. But the next question is from Dio Carvalho, data scientist at Novo Banco. And this question is, have you used any data augmentation techniques on your image to improve dataset variety and does model training? Data augmentation. So the question basically is like if you use data augmentation to improve your data set and to actually get more than the 5,000
like
images.
I showed in one of the slides, we do data augmentation and like translation augmentation and rotation to increase the data set. Yes. So I think that's pretty much it's a straightforward answer for me.
Perfect. And Leonor Fernandes, also from the data scientist from University Sonai, she's asking, does your system provide suggestion when accuracy is low? So, for example, when it's telling like your photo is blurry or lighting is too dim, if there is like any recommendation to the user?
That's a great question. Not currently, we don't do that currently, but it is one of the things that we might have in the backlog. Okay.
But when the image, like actually, let me use this one to the other question, like when the photo is not good to use, like there is a manual selection or you kind of tried not to?
So it is manually. So currently, because the project started, it was also the team taking the photos. And if we noticed that the photos were very bad, we do take out manually. So right now, like I showed, the way that we do it is if it falls below a certain threshold, we analyze the photo. But if it is very bad, we will not use it to train the model.
All right. Another one from Daniel Ribeiro, also from senior data scientist and tech lead from NOS. And this question is, have you tried any XAI approaches to diagnose why your model fails depending on the area of interest?
So I can say yes to that. We did try a lot of approaches and a lot of frameworks. We cannot disclose everything, unfortunately, but yeah.
Okay. And also, Alexandra Carvalho, kind of related with the previous question, is there any explainable reason for the different accuracies in the different regions of interest? Because some of them.
Okay, so yeah, it's going to be particular. So when it comes to the serial number against the other two the dimension and the DOT numbers. We are using a different type of approach, which is context-free, so this can also explain the difference. And it's random numbers, so it's a little bit more tricky. Between the other tools, they are in different regions. So the first thing, the pipeline starts with the bounding boxes. And as you can see, because they are in different regions and with different size, this can also lead to the different approaches along the pipeline. And also, the structure itself, it's not the same. So, for example, the DOT may be a little bit easier because they have a more, a more structured way. The dimension, it is in a certain structure, but has a little bit more of variability.
All right. And the last one from Nick, slightly on the other hand of data science, which is a great one, is how do you advocate for data scientist standards in a fast-paced environment? It's force that happen.
It's a really good question, and it is complicated because we are still working in our team, and I don't think we ever will have that perfect framework. One of the things that we try to do in our team is we do make a time to talk about this issue. So we do have meetings regarding the standards and how we should apply, but we are always researching. So we try different ways to different, setups that we can do and different libraries that we can try to make it easier. And we share, like, in the Teams channel. So every day there's, like, notifications there. Right. But it can be a little bit overwhelming, for sure. And nowadays we have, like, this Confluence where we get documentation about pretty much everything that we are doing in the team. But in Continental, which this is a great question, because in Continental we are just one of the teams. Other teams, they do have data science. So what we are working is also to bring, that knowledge to the other teams, and then we can consolidate a way to have these standards across all Continental and not just in our team.